Ever wondered how we went from cave paintings to Google Earth? Welcome to Class Bites. Today we're charting the incredible journey of map making from ancient scribbles to the digital age. For centuries, humanity has endeavored to understand and represent the world, an ambition captured in the ancient art and science of cartography. The earliest maps were not precise navigational aids, but rather stories etched onto clay tablets or painted on cave walls, depicting hunting grounds, water sources, and the immediate known world. These first attempts were practical, focused on administrative needs or delineating land boundaries. Over time, civilizations from ancient Greece and Rome to China made significant advancements. Greek scholars were among the first to apply mathematics to mapmaking, calculating the Earth's circumference with surprising accuracy, and introducing concepts like latitude and longitude, which laid the groundwork for a more scientific approach to representing our planet. For a long period, maps were handcrafted artifacts, blending geography with artistic and sometimes religious symbolism, often illustrating a worldview as much as a physical one. The age of exploration, spurred by inventions like the compass, demanded greater precision, pushing cartographers to develop new techniques and projections to aid sailors navigating vast, unknown oceans. The 20th century, however, heralded a transformation so profound it would forever change our relationship with the world and its depiction. The advent of aerial photography and later satellite imagery provided a perspective previously unimaginable. Suddenly, mapmakers could see and measure the Earth with unprecedented detail and accuracy, charting even the most remote and inaccessible regions. This technological leap was the seed from which a new discipline would grow, one that would take the static, two-dimensional map and turn it into a dynamic, interactive tool for understanding. This new field is known as Geographic Information Systems, or GIS. GIS is a powerful computer-based system to capture, store, analyze, and display all forms of geographically referenced information. Think of it not as a single map, but as a smart map, capable of holding countless layers of information stacked one on top of the other. The foundational layer might be a high-resolution satellite image of a city. On top of that, one could add a layer showing the road network, another depicting property lines, a third illustrating population density, and a fourth showing the location of schools and hospitals. GIS technology allows us to integrate, process, and analyze these different layers together, revealing patterns, relationships, and contexts that would be impossible to see otherwise. It transforms the map from a simple visual representation into a powerful analytical tool. At the heart of modern GIS is the torrent of data provided by satellites orbiting our planet. These satellites are equipped with advanced sensors that capture images of the Earth's surface across different wavelengths of light, including visible, infrared, and radar. This technology, known as remote sensing, provides a constant stream of information, allowing maps to be updated in near real time. We can now monitor deforestation as it happens, track the extent of flooding during a natural disaster, or observe the subtle changes in crop health across vast agricultural fields. The level of detail is extraordinary. Modern satellites can capture images with resolutions so fine that individual trees or cars are clearly visible. This precise, up-to-date data serves as the lifeblood for GIS, ensuring that the analyses performed are based on the most current and accurate information available. The true power of GIS, however, lies in its ability to perform what is known as spatial analysis. This is the process of examining geographic patterns to understand not just where things are, but why they are there. Spatial analysis uses various techniques to study entities based on their location, geometry, or relationships to one another. For example, an epidemiologist might use it to identify clusters of a disease outbreak and correlate them with environmental factors like water sources or population density. Urban planners can analyze traffic flow to optimize transportation networks, and businesses can study customer demographics to determine the best location for a new store. It moves beyond simple observation to ask complex questions. Where are the areas most at risk for wildfires based on vegetation, slope, and weather patterns? What is the most efficient route for a delivery truck considering real-time traffic? By analyzing the spatial relationships between different data layers, we can uncover hidden trends, make predictions, and ultimately make more informed decisions. The synergy between the timeless principles of cartography and the dynamic power of GIS has given rise to a suite of digital geography tools that have become integral to our daily lives. When you use a navigation app on your phone to find the quickest route, you are using a sophisticated GIS that combines road network data, real-time traffic information from satellites, and your precise location from the Global Positioning System. These tools are not just for experts. Platforms like Google Earth and Google Maps allow anyone to explore high-resolution satellite imagery, 3D terrain, and street-level views from their computer or smartphone. This democratization of geographic information has revolutionized everything from environmental management and disaster response to real estate and logistics. The modern map is no longer just a piece of paper. It is a living, breathing database of our world, a powerful lens through which we can explore, understand, and shape our future. Thanks for watching. Please like, subscribe, and comment with your thoughts or next video ideas.